Okay, here we are, starting chapter 6, Inequalities. So if you take a look at this first statement here, if you recall from algebra, if A is greater than B and B is greater than C, then what else must be true? A must be greater than C, okay? So we're going to use that a bit. And we're actually going to use it right here. This does have a little name if you want to jot it down. This is the exterior angle inequality theorem. So let's just refresh our memory, even what an exterior angle is and what's going on here. So if you take a polygon and you extend one of the sides, right? What you have created is an exterior angle. The exterior angle, remember, is always forms a linear pair with one of the interior angles. So 3 we would refer to as an exterior angle. What is angle 3 equal to? Yes. Right, the sum of its two remote interior angles. So if you add angles 1 and 2 together, you would get angle 3. You follow? So, angle 3, I have no idea what its measure is, but doesn't it have to be greater than either 1 or 2 by themselves? Yeah, if it's equal to these two added together, and neither of those angles could be 0, right? That would be impossible. I can't have an angle of 0. Well, I can have an angle of 0, but not in a triangle. So, if I have to add these two together to get this one, that means that the exterior angle has to be greater than either angle 1 or angle 2 by themselves. Does that make sense? Okay, so the measure of an exterior angle of a triangle is greater than either remote interior angle. Now, this chapter can get a little confusing because you're using inequality symbols and angle symbols. So I want to say angle 3 must be greater than angle 1. So try and make your inequality symbols very clear that it's an inequality symbol. Because if you just write it like this, like what even is that, right? It gets so confusing. Some people like to put the kind of arc over the angle symbols, which is fine. But that's just not in my nature, so I never think to do it. But if that's what you, just make sure it's clear if you're trying to do an inequality symbol, okay? So similarly, angle 3 must be greater than angle 2. And I could always say the reverse. Angle 3, or angle 1 must be less than angle 3. Angle 2 must be less than angle 3. Even though, yeah. Oh, sure, if you want to. Okay, so let's try, and you might be able to squeeze this in over on the side. I'm going to use a separate sheet of paper just so we can see a little bit better. But I'm going to give you a little diagram, and I want to see if we can reason our way around this. So let's say I had this. And I labeled some of these angles. Your 3, your 4, and your 1 and 2. So, given this diagram, I want to try and, let's prove it. Yeah, why not? Prove angle 2 is greater than angle 4. I have no values. I have no idea what any of the angles measure. Let's see if we can make something happen. Oh, but I have to give you something. Given, let's say we know that angle 2 is greater than angle 1. Okay. So if angle 2 is greater than angle 1, I'm sorry, I put my 2 in the wrong spot. 2's supposed to be here. Sorry. Sorry. Yes, as you should be. Okay, that should be better. Are we all right?
Yeah.
Okay. Okay. Now what can I do? I'm trying to get 2 greater than 4. Anybody have any thoughts? Always remember, like when you're trying to do something, think about the certain section that you're in. Jared.
You could say angle 1 is greater than angle 3.
You could. You could. You're right. But I think... Oh, wait. Yes, but 1's greater than 3. Yeah, okay. Let's go with it. So, angle 1 is greater than angle 3. And how do you know that?
The theorem you just gave us.
Yes, exterior angle inequality theorem. Okay, now what? Dakota?
You could say that 3 is equal to 4.
Yes. Okay. Now what do you want to do?
So angle 1 is greater than 4. Substitution.
Yes, angle 1 must be greater than angle 4. So we're just taking our line 2, swapping out 3 for 4. Substitution. And now we are ready to say angle 2 is greater than angle 4. Do you see how? Okay, let's start right here. 1 is greater than 4, right? And look at our line 1. 2 is greater than 1. So 2 is greater than 1, and 1's greater than 4, which means 2 must be greater than 4. So what do you say here? You just write property of inequalities. So that was the very first thing. If A is right here, if A is bigger than B and B is bigger than C, then A is bigger than C. So they don't have to be so bad, yeah. So angle 1 is an exterior angle of this triangle, right? Right? So that's the exterior angle inequality theorem. An exterior angle has to be greater than either of its 2 remote interiors. Right? Because it's equal to the sum of them. So let's say that there was an angle 5. Angle 1 is equal to 3 plus 5. So it has to be greater than either one individually. Hooray! All right. So, do you guys remember the converse and the biconditional and the...
Yeah, I think so.
Good, because we're doing like part 2 of that. So that's it for 6-1. Let's take a gander at 6-2. So let's see what you remember. We have already talked about the conditional statement. Those were the if-then statements. If this, then that. So a conditional statement, do you remember how we wrote it in symbols? Yeah. So a normal conditional is written as if P then Q. The hypothesis of a statement, remember, was P, the conclusion was Q. So this is something like, if today is Monday, then tomorrow is Tuesday. So then the converse, how did you write the converse symbolically, Colby? Right, so it'd be if Q, then P. So then the example I just said, it would be if tomorrow is Tuesday, then today is Monday. And then what was the biconditional?
If and only if.
Right, that's using the words if and only if. Yes, you can abbreviate it as IFF. If and only if, IFF. And then in symbols, what's that? Do anybody remember? With the P's and Q's, what it looks like for biconditional? It just had it was a double arrow because you can go either way. We like our definitions to be biconditional, so 2 lines are parallel if and only if they are coplanar lines that don't intersect. And it's true that way. It's also true conversely, if two coplanar lines never intersect, then they are parallel lines. So definitions, we want to be really clear. Is it a false statement if you say if 2 lines are parallel, then they never intersect? That's true, right? But was the converse true? If 2 lines never intersect, then they're parallel? No. So the biconditional is making sure that it's true both ways. That's why we adapted our definition of parallel lines to include the word coplanar. So, anywho, that is old news. That was from chapter 2 that we talked about. So if you need to brush up on those, look back there, okay? Now we have some new things we can do with them. The first one is negation. This is just saying the opposite of what it is. So instead of saying if today is Monday, you would say if today is not Monday. If I said something like, if I don't have my homework, then I'm grounded. If I negated that, it would be if I do have my homework. Right, so negation is just saying, adding the word not, or if not's already in there, then you would take it out. Okay, so the opposite of a statement. To write that symbolically, we just put a squiggle in front. So that you would say it out loud as not P or not Q if you were doing Q. All right, so that's what negation means. Now the inverse is when we negate both the hypothesis and conclusion. So let's do an example. I have one here. So I'm going to write it down here where we have a little bit of room. Let's assume my original conditional was, if it's sunny, then we go. Where are we going? I have no idea. Use your imagination. So if I were to write the inverse, I'm going to negate both the hypothesis and the conclusion. So, who wants to give a shot what that would look like? Caroline, go ahead.
It's not sunny, then we don't go.
That's exactly it. So that would be the inverse of that statement. If it's not sunny, then we don't go. Okay, so that's all the inverses. Notice I didn't change the order of anything. I just said the opposite of both sides. Okay, so let's go back up. We have one more word, contrapositive. This one's my favorite because you get to do everything you could possibly do to a statement. You're going to switch it, you're going to do the converse, and you're going to negate it. So here's how I remember what it is. Contrapositive is a big, long word, so I have to do a whole bunch of work. I'm going to switch hypothesis and conclusion and negate them. Okay? So that's spelled out for you what you're doing. But in practice, contrapositive. And sometimes we get lazy and we write contra plus for positive, right? So I always go back to my original conditional. So I want to look at my conditional. I want to switch them and negate them. Does anybody want to give it a shot? What that might read? Go ahead, Dakota.
We don't go if it's not sunny.
You're so close. Just leave the if in the beginning. So if we don't go.
Okay, so if we don't go, then it's not sunny.
Yes, there it is. So contrapositive. I'm taking, again, that conditional. I'm going to swap them and negate them. If we don't go, then it's not sunny.
I thought negation was only one of the things.
So negation is just the saying the opposite of either hypothesis or conclusion. Inverse is when you negate both of them, your hypothesis and your conclusion. So when you
Both then negated. Okay.
right, then you've written the inverse. Brad?
You could do negation.
Yeah, no, I just thought it was negation.
It depends. So you're only going to negate one thing at a time, right? So if I made a statement like, my name's Mrs. Sabia, right? If you negated that, it would be, my name is not Mrs. Sabia. If I want to write the inverse of a statement, I negate both hypothesis and conclusion. So then that would be something like, if you teach geometry, then you teach math. Okay, let's just do that, right? So then if I wrote the inverse of that statement, it would be, if you don't teach geometry, then you don't teach math. You're negating both parts. Does that clarify? Okay, so you can negate any statement you want, but if you negate a conditional's hypothesis and conclusion, you have written the inverse. Okay. By the way, so let's just write in symbols the inverse. Normally it's if P then Q, right? So if you're going to do the inverse, you're going to do not P, then not Q. So how do you think that the contrapositive would be written in symbols?
There's a double arrow.
It's not Q, then not P.
It's not Q, then not P. Yes. Because you want to swap them and negate them. Okay, and then I just have one more little bit to talk to you about Venn diagrams, and then we're done with section 2. Look at this. Moving right along. I assume you all know what a Venn diagram is, correct?
Circles.
Yes. I went to a school committee meeting like 2 weeks ago for my town where I live. Oh my gosh, and they had a Venn diagram up that was like improperly done, and I could not focus on anything else. And it had nothing to do with math. It was just about like, oh, but I just couldn't stop looking at it, and I'm like, But anyway, so Venn diagrams, yes. If I make a circle here, I could have another circle, and then, I don't know, so like, oh, what could you do? I don't know, anything. You could do people that like the movies, and then over here could be people that like the beach, and then you would have a cross-section of people that happen to like both, right? Or I could say something like, let's say in this circle is everybody that loves movies, right? Do you think that everybody that loves movies loves horror movies? No. But everybody that loves horror movies must love movies, right? Because so anyway, so I could have a subsection of what's in there, right? Take, we're going to do one with Tantascwa students. So here's my statement. All Tantascwa students are human.
I would hope so.
Yes. All Tanty students are human.
I hope so.
Mm-hmm.
I mean, you never know.
There was an incident with some ducks a few years ago, but... Oh.
They were students.
No, but they were honorary almost. Okay, so let's see. So let's say that this bubble represents all humans. All humans are in this bubble. Is every human a Tantascwa student? Of course not. But is every Tantascwa student a human? Yeah, so within this bubble, I'm going to have Tantascwa students. So I'm going to make a statement, and you tell me what you can conclude, if anything, okay? So we know that our given statement is true. So let's try this first one. Let's say I tell you, Bill goes to Tantascwa. What can you conclude, if anything? He's got to be a human, right? If he goes to Tantascwa, that means he's in this circle. And that circle is within the human circle. So I can conclude, so if that's my hypothesis, my conclusion could be Bill must be human. Okay, let's try this one. How about I say Bill is human? Can you make any conclusions? No, other than just restating the fact that he's human, which isn't a conclusion at all. So I have no conclusions here. No conclusion. Let's try a third one. How about Bill does not go to Tantascwa?
He may not be a human.
Yeah, I don't know anything. Bill does not go to Tanty. Does that mean that he's a human?
No.
We have no idea. Bill could be a dog. He could be a duck. So I have no conclusion that I can draw there. How about Bill is not human? If I tell you that,
And he doesn't go to Tantascwa.
right, then you would know for a fact that he does not go to, he is not a Tantascwa student. Okay, so we can conclude Bill does not go to Tantascwa.
That's an inverse.
Mm-hmm. Okay, so let's see. This one, if I gave you that, this one is saying not P, and this one's saying not Q. All right. So that's all I really wanted to cover today. I do have a homework assignment for you. Let's see if I could, maybe I can streamline it a little bit. All right, I was gonna have you do 5 through 8. Let me look real quick. And let's stop this.